Okay, let us carry on. Okay, focus on STPM 16. Let's try some question there. Okay. As I say, these are all the formulas that you need to remember for this topic. And the only way to remember it is you do question and know how to apply it. So let us try some question. Which of the following statement about the motion of charged particle entering the uniform magnetic field is not true? Okay, A, path of particle is parabolic if the direction of motion is parallel to the direction of magnetic field. Is it true or false? True or false? True or false? True or false?
A is false.
What should be the answer be if it's A? What should happen?
The path is parabolic in an electric field.
What should it be? What should it be? If it's moving in parallel to the magnetic field, what should the path be?
Circular.
It should be the same. Constant velocity. Right? As long as it's parallel, it doesn't matter parallel or anti-parallel, you still continue with uniform velocity, not force acting. Path of particle is circular if direction of motion is perpendicular to the direction of magnetic field. Yep.
Yep.
Okay, this is correct. The magnitude of the magnetic force is directly proportional to the charge of the particle. Is it true or false? I'm just trying to review with you, see whether you understand what we have studied. That's all. That's why I'm going through one by one with you. Magnitude of magnetic force is directly proportional to the charge of the particle. Is it right or wrong? Why so long?
Yeah, C and D also correct. That means so the answer is A. They say not true.
True. F is proportional to the Q, correct? Magnitude of magnetic force is maximum if the direction of motion is perpendicular. This is true. Okay. Good. Answer is A. All right. The magnitude, the diagram shows 3 long parallel wires, X, Y, Z, each carrying current, the same current. If the distance between X and Y and Z, or the distance there is the same, which of the following figure shows the direction of force acting on X, Y, and Z? Yep. What is the answer?
Donkey.
Donkey. Between X and Y, there's attractive force, correct? Between Y and Z,
No attractive force.
a repulsive force, correct? Yeah.
So answer donkey.
Between X and Z, you have a repulsive force. So that repulsive force is weaker. Okay, good. Let's try the next one. This one. You have to work it out. Not so simple. diagram shows two paths of positive ions in a mass spectrometer. Point P is the effect of the positive ion of mass M. Point Q, that's your point Q, is the effect of positive, excuse me, positive ion of mass M2. If the two positive ions carry the same charge, M2 is equal to, so that's where they enter. The arrow show you that's where they enter. So how to do all that? What's the answer?
D over D plus X.
What's the answer?
C.
Right, let's see. Right, always go back to the, if you can remember, good. If not, go back to magnetic force equals to centripetal force. Then you want QB over V. Right, that one take down. Equals to M over R. Right, because your Q, your B, your V is the same. That's why we subject it. So this one got MR left. So for M1, right? M1, that's the distance. The total diameter is X plus D divided by 2 to get the radius. Then M2, same thing, M over R, M2. M2 is D. D is the diameter divided by 2 to get the radius. And then you can cross multiply. The 2 will go off. Okay, C. Okay with that? Can? Anything not clear?
Oh, so you take the R X plus D over 2 lah. Oh, like this you do.
Because my B is constant. My Q is constant.
Yeah.
So V and V cancel. I still got one V. I take it down.
Yes, and you bring the V.
So I got
divide it,
M and
then
R,
it
that's all.
equals it.
So
Yeah.
M and R is a variable. So I
Yes.
apply to M1. M1,
Oh,
the diameter is D plus X. So I divide by 2 to get the radius. Now I
yes.
apply to M2. The diameter is D. So radius D divided by 2. That's all. Then the 2 and the 2 can cancel off. And take the D up. That's why I get the answer. Okay.
M1 is X plus D divide 2 and the other one is D divide 2 alone. Oh yeah, D divide 2 is the
M1 is
original
D,
one.
is P. M2 is Q.
Oh, P to O and then Q to O. Right.
Yep.
Okay. Hey, but then why divide to O? Yeah, to find the radius. Sorry. Radius.
You want radius,
Okay.
not diameter.
Yes.
This one?
This one is donkey.
A beam of proton move in a straight line through a region which has uniform magnetic and electric field. The electric field is produced by two parallel plates 2 cm apart. Potential difference 1000 volt. If the magnetic field is given, the speed of the proton, right? So from they give you both potential difference, distance between the plate, go and find the electric field. Since you got magnetic field and electric field, then magnetic force equals electric force. And Q cancel, you got V is E over B. As I say, can memorize, go ahead. You cannot, work it out step by step. And put in your value for your E, put in value for B, calculate. Okay, donkey. Happy with that? And we go ahead.
Yeah, we can.
Okay, let's go ahead then. it not obeying me?
Huh?
Sorry, my slide not obeying me. Sorry, having some problem.
Yeah.
Okay, let's carry on. Okay, don't bother about this one. You can try the rest yourself. Let me just do some selected one. This one, they won't give you lah. Of course, I show you to the Fleming's left-hand rule. The diagram shows a positive charge moving through a uniform magnetic field at a velocity v in the positive z direction. If the magnetic field is in the positive x direction, the magnetic field is here to the right. The magnetic force acting on the positive charge is in the which direction? Know how to read? Positive charge is moving outwards towards you or out of the page. So where's the direction of magnetic force? Keep on doing the question until you get it perfect. You get it very fast. You're very slow.
C.
Right, let's see. That's your magnetic field. Draw on the diagram, is all right. Draw on the diagram, then you can see magnetic field is where? And magnetic field there. Right, current is coming out. Okay, looks like you're right. C, correct. Okay, let's go to number 8.
Number 7, right?
Yeah? Don't tell me you look
Go
at the
back
answer.
again. Yeah, I did. Only for
Why
this
are
one.
you cheating? You cheat yourself only. You're supposed to use your fingers and throw it yourself, honestly. You cheat yourself, don't cheat me.
Okay, no.
Don't know how to do.
No, I mean the red line, right? Teacher, that's magnetic
There is to
field.
show you so clearly. There's your B. There's the current coming out. So the force is going up.
Force going up. Hello?
Yeah, what's the problem?
So force is going up, right? Sure.
Yeah, it's so clearly show you the diagram there.
Okay, now I get it.
Diagram is so clear. Okay.
Okay.
Hall effect cannot be used to measure.
C.
Huh?
Mass of charge carrier.
Go back to the formula. All voltage depend on your BINET. Okay, you're right. Mass or charge carrier. No mass there. They cannot use to measure your mass. This one. Diagram shows a 40 cm straight rod. It's a 40 cm straight rod. Current 20 ampere. Field is going in. Right? At an angle theta. 2 Tesla. Magnetic field acts in the horizontal plane at an angle of theta with the direction of the current. So you can treat as going in now. If the weight of the rod is 8 Newton and magnetic force is just enough to balance the weight of the rod, what is the angle theta? Okay. Yep. What is the answer?
Fm equals to BIL. Magnetic force equals to BIL.
Magnetic force equals to the weight, that's all. Weight pulling it down, magnetic force is upwards.
So the weight is 8 Newton lah.
Yeah, magnetic force downwards. Magnetic force is upwards. Weight is downwards. So magnetic force is VIL sine theta. Weight is mg sine theta. Okay, VIL down. Cross multiply. You got that. Put in your value. Okay. Your weight is 8 Newton. B is 2. Current is 20. L is 0.4. Get 30 degrees. Okay.
Okay.
So answer is A. Okay, how about this one?
Donkey.
Diagram shows a trajectory of two charged particles P and Q directed perpendicular into region of uniform electric field with same velocity. Both of them same velocity. One go to the right, one go downwards, one go to the upwards. If the radii of the trajectory are the same, what are P and Q? What do you say?
D.
Donkey, is it?
Yes.
Okay, as usual. Both of them must be either positron and electron. But then you have to use your Fleming's left-hand rule to determine where is the direction of the force. So the direction of the force, okay, so you're right. Oh, you haven't cheating me by looking at the answer. Right? They have the same mass, they have the same velocity, same field. So they will have the same radius. That means they must have the same different charge as all. Okay, donkey, correct. Positron is the antiparticle of an electron. Right? That means it is the same mass as electron, is charged positive. Okay. The rest you can do yourself. Let's try some structure question before we end for the day.
Oh, the other one. Oh.
You have to do your own, unless you want to spend another hour.
Oh, no.
Explain what is meant by magnetic flux. Density of magnetic field is 1 Tesla.
The magnetic flux density is 1 T when the magnetic force on a charge of 1 C moving with a velocity of 1 ms91 at right angles to the magnetic field is 1 Newton.
Okay, basically we are just using this formula. 1 Tesla is the magnetic flux density of a field or magnetic field when the force of 1 Newton acts on 1 Coulomb of charge moving with a velocity of 1 meter per second perpendicular magnetic field. Okay, the diagram shows a particle of charge Q moving with velocity V. I just show you the diagram, they're very kind. Constant height in a uniform magnetic field. The weight of the particle is W. Derive the expression for magnetic field and draw a diagram to show the direction. Yep. How to do that? Where should be the magnetic field? Yeah, apply your Fleming's left-hand rule. Your current is moving to the right. Where is the magnetic force? That's the first thing to determine. Where should your magnetic force be? And then you can determine your magnetic field. Yep. What's the problem?
Oh, this one need to draw. The force is up.
Yeah, the magnetic force must be upwards to balance the weight. So where's
The
the
current
magnetic
is to
field?
the right. The current is to the right. So that means it's between the force and the current.
Yeah. Where's the magnetic field?
I mean, it's cutting the intersection between the force
Where
and
is
the
it?
current larger.
Is it right? Is it going to the right? Is it going to the left? Is it going up or going down?
Right.
How can be right? Right is taken by the current already. It's either going in or coming out. You're still having problem using your Fleming's left-hand rule. I'm worried for you. Going so many times with you. You still haven't learned anything. Yeah, that's all. Okay.
Okay.
Okay. Let us have I completed that? Let us try one long question. Okay, let's try this one. Number 2. 3 parallel forces X, Y, and Z on a smooth horizontal surface are spaced a distance r apart. The wire carry the same current in the direction as shown in the diagram. Derive an expression for the force per unit length on wire Z. That's the wire Z. State the direction of magnetic force. Right? Should be able to do that. Basically, we are just using this formula. So remember that your like current attract. If different direction, unlike current, will repel. That's important. So between X and Z, right? X and Z, you can put a negative sign there if it's going to the left. If it's going to the right, it's a attractive force. That means it's going to the left. You put a negative sign there. Choose the right as positive. So we're just using the current is the same. Right? 2 pi. R is R plus R. Then put in your value. Right? For the resultant on Z. Right? We take our mu naught out. That's your mu naught. We take our I square out. Yeah, 2 pi out. So this is minus 2R. That's your X and Z. Then between Y and Z, between these two, right? Between these two, as I say, the same formula. We are just using the same formula, except now the distance is R. That's how we get R. Positive because it's to the right. The two force between these two is a repulsive force, so it's going to the right. So we get that. That's all. State the direction of the magnetic force. Where's the direction of magnetic force?
Direction of magnetic force. It is away from wire Y.
Okay. Okay.
Okay.
Let me see how more we can do. Let me see what question to do. Okay, let's do number 3, essay question. Then let's call it a day. Do one essay question. Define the
One
magnetic
and done.
Define the magnetic flux density in terms of force on charge. Draw a diagram to show the quantities involved. From the definition, derive the expression for the force on a current carrying conductor in magnetic field. Ken, how to define it? Yeah, how will we define it? I always still remember this formula. BQV, F equals BQV. Right? So it's basically from that magnetic flux density B, yeah, is the force on unit charge moving with unit velocity, and this formula is for perpendicular to the field. Velocity is perpendicular to the field, that's all. From the definition, derive an expression for the force on a current carrying conductor. Right? That's all.
Okay, sir.
There's a force on electron. Then
Teacher,
total
can you
force
just
on,
give me 1 minute?
yeah.
Okay, 1 minute, sir. Hello, sir.
Yeah.
Yeah, can continue, sir.
Yeah. Start with the definition. Force on one electron. Then total force on n electron. That's all. Right? And then look at the length of the conductor. Cross-sectional area A, length L, carrying n charge carrier per unit volume. Each with drift velocity, mean drift velocity V. Get that equation, NEAV. And then what is A? Right? That N converted to number, divided by volume. Cross-sectional area divided by L. So A and A can cancel off. Okay. So A and A can cancel. We got NEV. NEV. The L can take across there. So you get IL. Then you place that NEV into here. Because IL. That's all. Make sure you know how to derive the equation. Okay. Refer to your note anyway. I'll send to you this one. Okay. A rectangular coil A, B, C, D with sides 3L, 2L, carrying current I. Right? All these are I. This one is 4I. Next to a long XY, carrying current 4L, derive an expression for the resultant field along. Okay, we have to change in 10 minutes time. We will stop in 10 minutes time. So I'm going very fast. Along BC, due to current in XY and the side AD. Okay. So we are just memorizing this formula. Field due to current carrying conductor. So we are looking at one, right? BC due to XY and AD. And we are just using this rule to get the direction of the field. So the field due to AD, there's your AD, along BC is inwards, right? Inwards. While that due to XY is outwards, right? That one coming out at this direction is coming out. AD. Think of it as a circle. We are looking at this side. This one we are looking at the other way. So that's why it's going in. That's why I put a negative where it's going in. Right? We take the mu naught out. We take the 2 pi out, I and D only. So I is 4I. Okay, coming out, and then L. Now by L. And minus your, this is your I. Current is the same in this coil. Distance is 2L. Okay. And we get that answer. Okay, the next part. Along AD, due to along AD, this one. Right? Just now we are looking at the BC. Now we are looking along AD due to XY and due to BC. Okay, same thing. We just use the same formula between these two. Right? Between these two. Right? Remember, it's coming out. That's why it's positive. The distance is 2L plus L is 3L. The current is 4I. And between these two, right? Distance is 2L. Current is I. And the rest is just put in the value and calculate out. Hence, reduce the resultant force on the coil. Right? BIL, that's all. Find the resultant field. Right? Remember, both of them are coming the same thing, same direction, outwards. These two fields are outwards. We choose the direction coming out is positive, going in is negative. That's why we can add these two together, right? Because they are vectors. And I is I for the coil. L is 3L, that length. Then we get the answer. Okay?
Okay.
Anyway, yeah, I'll send you the tape. You go and look at that. I think we will complete today. We'll stop here. See you on Wednesday.
See you on Wednesday, sir.
Okay?
Sir, I need I need another thing, sir.
Say again.
I need to ask you something else, sir.
Yeah.
My sister, right?
Yeah.
Unfortunately, she also gonna join STPM.
Going to join us?
No, STPM.
Oh, but she is in September, October.
No, July 26.
July 26. I thought she just passed her SPM.
Yeah, that's why she only got her result in June only, right, teacher? And so far they already giving already. 2 days ago was the last day to